Math. We have 3 sections left from this chapter: 3.7, 3.9, and 3.10. And then we'll start reviewing for test 2. So I'm hoping to finish 3.7 and at least start 3.9. We'll see what we can accomplish. I have all my devices ready here. I have my 3.7 up, and I have my calculator, so I'm ready to start. So let's start with 3.7. Basically, rates of change in other sciences. Like physics and beyond. So what does this mean? It's an application of differentiation. And I'm ready this time. I printed out 2 graphs to discuss in 3.7. I don't have anything new. We just need to practice. I don't have to say anything. I don't have anything to say. So I printed out, which graphs I printed out? I printed out this graph, and I'm going to stop sharing in a moment. The graphs of position function. So this is the distance function or position. So I'm going to write here position function. T is measured in seconds. Okay. And they are not telling us what S is measured in, but let's assume it's in feet. Okay. So feet and time in seconds. Fine. When is the velocity of each particle positive? So part A, velocity positive. So we're only talking about A. When is it negative? So velocity negative. When is each particle speeding up? Speeding up. And what is it slowing down? Part D. Okay, so this is problem 6 in 3.7, in which we're just looking at all sorts of different applications. Okay. Now, is this graph here clear? Do you want me to graph it again? Maybe I should. Let me do that. So I'm going to try to mimic that, but I'm going to come back and read maybe from there. Okay. So it starts kind of this. At 3 comes down, and then it goes up. Okay. So I hit 0, 1, 2, 3, 4, 5. First question is asking us, so remember this is the distance. Distance function or position. The distance or position. In other words, this function gives us the position of the particle at any point in time. So at 1 second, the distance is this. At 3 seconds, the distance is this, and so on and so forth. Okay, so when is the velocity positive? Well, positive velocity means positive slope of the tangent. In other words, S of t is increasing. Okay, so let's take a look. Here, the slope is positive. Here, the slope is positive. Here, the slope is positive. So the function is increasing. Here, the slope is positive. Here, the slope is positive. Here, the slope is positive. The function is increasing. So when is the velocity positive? So from this graph, I think it's quite similar. So it's positive between x being 0 to 1. And it's also positive from 3 to the right. And so on and so forth. So I will say in part A, velocity positive on the interval 0, 1, union 3, infinity. That's where the velocity is positive. Any questions before we continue? Any questions? I need my ruler handy here. Okay. Velocity negative. Okay, when the slope is negative. So here the slope is negative, here the slope is negative, here the slope is negative, and that's it. Here's positive, so then the function is decreasing. So when we talk about velocity being negative, we are talking about the distance decreasing. Okay, so when does this happen? On the interval 1, 3. Notice that nothing here is closed. They're all open intervals. Of course, at infinity it has to be, but everywhere else has to be also open. When is the function speeding up? Now, let's talk about the velocity being positive or negative one more time. Let's say I have a particle that does this. So it goes this way for 2 seconds, goes this way for 3 seconds, comes back for 5 seconds or 4 seconds, it doesn't matter. Well, in this particular situation, between this point and this point, the velocity is positive. It goes in the positive direction. Between this point and this point, the velocity is negative. The particle goes in negative direction. And again, between this point and this point, the velocity is positive. Okay, so the particle can be speeding up in the positive direction, or it can be speeding up in the negative direction. So even when the velocity is negative, the particle could be speeding up. And you can say, but I can never drive with negative 60 miles per hour. What are you talking about, negative velocity? What is this? You can call me, I'm saying to you, I'm driving, but I will never say that I'm driving at negative 60 miles per hour. What is this negative velocity? How is it possible? It's all about direction. It's all about direction of the velocity. It's not actually saying a negative. Okay? Or it could be decreasing. But it doesn't mean negative. It's all about direction. Or as I said, it may mean decreasing. Okay. So coming back here, when is the function speeding up? Okay. So the function is speeding up. Let me just explain one more thing. So speeding up, one situation is when the velocity is positive and the acceleration is positive. I meant to write positive, but I wrote negative. Why is that? Nobody knows. There is another chance, another possibility for speeding up. when the velocity is negative and the acceleration is also negative. So a particle can be speeding up when both vectors, if you want, or both functions are increasing or both decreasing. Why is that? They are not working against each other. They are not working against. We are going to look at the problem in a minute. So if the two forces work together, it means that they're both positive. The particle is speeding up in this direction. If they're both negative, it means that the particle is spinning up in this direction. But when is the particle slowing down? In which situations? Anyone wants to give it a shot?
When velocity is positive and acceleration is negative.
Excellent, thank you. When they are working against each other. See, imagine you're flying from here to New York, let's say. And if there is a tailwind, the two forces are working together to get you there faster. But if you're flying to New York and there is a headwind, you're going to get there, but in more hours or more time, more minutes, because it's about minutes, more minutes than otherwise, right? So if there is a tailwind, you get to New York in half an hour. I'm just making stuff up. But if there is a headwind, you get to New York, but in 45 minutes, because the headwind will slow you down. So if the two forces work together in any direction, in positive or negative, then the particle is speeding up. But if they are working against each other in any direction, then it's slowing down. So velocity positive, acceleration negative, or velocity negative and acceleration positive. Okay, so I'm going to copy this graph because I want to answer these two questions, but I don't want to put more stuff on this. So I'm going to copy, and this is another graph that I want to go through. So I'm going to copy the graph right here. And it starts as a maximum here, then a minimum here, and it goes up. Okay. So now the question is, when is the particle speeding up? So that's part C. And part D is slowing down. Okay, so let's take a look. So let me use a different color. Can I find anything else? Yeah, maybe this one. Okay, so here the slope is positive of the tangent, which is the velocity. And this is smaller. So this is big slope, but this is smaller slope. And this is smaller slope, and this is smaller slope, and this is definitely 0. The rate of change of distance with respect to time is 0 here. The velocity at 1, v of 1 is 0. So the particle is slowing down. This is big slope, smaller slope, smaller slope, smaller slope till 0. I'm jumping. Here, the velocity at 3 is again 0. So then it's this slope, and then this slope, and then this slope, and this slope, and so on and so forth. Obviously, this is increasing. So the particle is speeding up. Let's see what happens here. So this is a slope that is negative. This is a slope that is negative. till a certain point. I don't know exactly where the point is, right? So negative, bigger negative, smaller negative, 0. So this is a point where something happens. So speeding in the negative direction now, big slope, smaller slope, right? Because this is a bigger negative. Oh, I'm sorry. So this is negative, small. This is bigger negative, right? So this is this slope, not too bad, but this one is this, right? So this is this slope, but this one is more acute, more difficult to walk or climb down on this one than on this one. Much milder. This is much stronger, more acute. So negative, not too big, very big if you want, till this point. Well, what happens next is this slope is smaller than this. Still negative, but smaller in absolute value, and then smaller, and then 0. So the function is slowing down, speeding up, slowing down, speeding up. So I'll say slowing down between 0 and 1, speeding up between 1 and 2, slowing down 2 and 3, speeding up even if this is in the positive direction and this is in the negative direction. So between these two is going this way, between these two is going this way if it's a particle, and between these two it will continue forever in the positive direction. Who cares? Slowing down to speed 0, increasing, going backwards, increasing till this point when it starts leveling off again, and then increasing. Any questions on this problem?